Hi, this is Dr. Churchill, returning for Astronomy 308, and this is Into the Final Frontier. We are in Module 2 of the space race, and today's topic is going to be the Soviet moon program. So we have now reviewed Mercury, we've reviewed Gemini, we've gone through the Apollo program, so we've built ourselves up basically to 1972 in the American program, and even to 1975 because we talked about the Apollo-Soyuz test project as well. So today we're going to go back again. We had also, in the midst of the discussion of the American program, did a small part one of the Soviet space race, which basically was from Sputnik forward to about 1966 with the fall of the program when Sergei Korolev died in 1966. And so in this lecture, I'd like to go back a little bit into that period with Korolev and talk about the development of the moon race and the moon program that the Soviets had. And then we'll move forward through the 70s into the era of the great Soviet space stations and talk about that in the context of the American efforts. And finally end with sort of a bit of what happened with the Soviet space shuttle, and also then talk a little bit about the Roscosmos, the modern version of the Soviet space program, which in 1989, 1990, 1991, changed from these segmented design bureaus under the Soviets into Roscosmos, which was a unified space program under Yeltsin, their premier who followed Gorbachev. So anyway, let's bring up the slides today. Today, like I said, we'll talk about the Soviet moon program. And there are 5 players that get discussed in today's lecture. There's Chelmy on the left here, and Korolev, which we all know well and love, and then Glushko, his arch rival, who is the engine builder, and then Mission. And Mission was actually working underneath Korolev and became Korolev's replacement when Korolev died. And then Barman, who is, now Chelmy and Barman are kind of leaders of other design bureaus. And so they were, in a sense, parallel and in competition with Korolev and Mission. And then, of course, Glushko built the engines, but he and Korolev had fallen out. Remember, they had a rivalry on the fact that Glushko had denounced Korolev under Stalin's purges. And for that reason, Korolev had gone to a gulag and done hard labor for 10 years. So there was not a lot of love between those two people. And as they were designing their moon rocket, Korolev and Glushko basically had their last final falling out, where they just hated each other's guts, and there was no way that they were going to work with each other. And that caused a big problem because Glushko felt that the engines that Korolev wanted to use were too dangerous. And Korolev felt that he really had no other opportunity to get to the moon and beat the Americans. So he went with a different engine builder, and that person wasn't as experienced, and they had a lot of problems. So that's kind of one of the things that that disunification amongst these individuals at the top layers was one of the reasons the Soviet program struggled. Across the bottom here, I have some pictures which really prove to you, in fact, that there was a Soviet moon program effort. This is actually an artist's rendition of what their lunar lander looked like. And what you might notice about it is very small, and it actually only would hold 1 cosmonaut. So if the Soviets had landed somebody on the moon, who would have probably been Alexei Leonov, it turns out that it only would have been the 1 individual who landed at a time. Here's an actual true built lunar lander that they have in their museum now. That was kept completely secret from the Western world during this period of time. Here is the Soviet moon rocket. It's called the N1, and it literally is as tall as a Saturn V, but it is a very different design than a Saturn V. And here it is being brought on rails to the launch site. So along this journey that we're going to talk about, we're also going to talk about the reasons that the Soviet moon program failed. So let's talk about preparations for the moon landing. While we were talking about Apollo 8 going to the moon, and then Apollo 9 and its testing, and Apollo 10 going to the moon, and 11 landing, the Soviets were not quiet. They were doing things, and the CIA had spy satellites carefully watching them. But the Soviets were doing everything as secretively as they possibly could. Now, you might remember that Apollo 8 was meant to go into Earth orbit and do a shakedown mission with the Lunar Landing Module and test the full integration of systems of the Apollo spacecrafts. But they didn't have the Lunar Landing Module built in time for that mission. And then it turned out that the CIA saw the giant moon rocket on the launch pad for the Soviets in September, October, and they were worried that they were going to beat the Americans around the moon. And as we'll see, there were multiple moon projects going on simultaneously. Another reason that the Soviets struggled, because you had competition between three programs. And one of those programs was just to get an astronaut to the moon and around it before the Americans did. Now, as part of that, there was this Zond spacecraft that flew on a Proton rocket. And here we are in September of 1968, which is before Apollo 8. They had flown this around the moon and had it splash down in the Indian Ocean. So they clearly were clearly getting close to striking distance. And that really concerned the United States, because they really didn't know if their Zond spacecraft could carry a human or not. The intelligence just wasn't there. Okay, so I just wanted to bring that point up. But before I move down this list on the right-hand side a little bit, I just want to let you know here that there was an official decree. It was sponsored by the government. It was in, legislation that was signed off. This is called Decree 655-268 on work on the exploration of the moon and mastery of space. It was adopted in August of 1964. So this is about the time that the Americans had Ed White walk in space, and Alexei Leonov for the Russians had walked in space. So this is just at the beginning of the Gemini program in America, to give you context that this decree was signed into legislation. So anyway, it turned out that they were going to use lunar orbit rendezvous as their mode. It's not clear if they came up with that separately or whether they had listened in, because everything was so public with the American program. All right, so you can see here in 1968, they had already started to have a fly around the moon. And then in 68 was the first time that they did some rendezvous, which we had mastered back in 1965. And then in 68 here, again, you have an attempt at docking. So we had done that in 65, 66 with Gemini. And then the Zond 6 spacecraft flew around the moon. But they had a little problem in that the re-entry spacecraft depressurized during landing, and there was a crash. So they were struggling with some problems there. Then they finally had a successful docking in 1969 in January, which is, I believe, about the time that Apollo 9 was flying. And then Soyuz 5, finally successful docking. Zond 7 in August of 69, this is after Armstrong and Aldrin had landed on the moon. They actually had a successful fly around the moon and successful landing. So it still wasn't manned. They've never sent a man out to cislunar space or to the moon. And et cetera, et cetera, et cetera. You can see what I'm trying to demonstrate here is that they did have a program. They were moving forward, but it was all in secrecy. These are some of the rockets that you see being developed in the Soviet Union. This here is the Proton. Here's the Soyuz lift rocket. And then compared to the Soyuz, here is the N1 moon rocket. So you can see how big this behemoth is. And again, it's about the size of a Saturn V rocket. And you can see that the Soyuz here, these are basically scaled up versions of Korolov's R7 rocket. That was such a successful rocket. After Korolov's death, They had a lot of technical issues. They had a lot of administrative shifting that had to go around. And there was nobody that really was capable of being Sergei Korolev in terms of his ability to manage people, get people to get things done on time, quality control, all of this that really happened. In addition, he was instrumental in obtaining financial support. I mean, there was always this competition between the design bureaus, and Korolev had to fight very hard for his piece of the pie. What if Korolev had lived? What were the plans? And so with the N1 rocket, February of 1969, the N1, okay, it fails at T equals 68.7 seconds. Now, if you've seen the Challenger accident, the Challenger exploded at 70 seconds into launch. And so this is basically the equivalent amount of time that the N1 had lifted off the pad and then exploded. On July 3rd, before Armstrong and Aldrin actually flew the Apollo 11 mission, the N1 was sitting on the pad, and they did a launch on July 3rd, and this was an absolute catastrophic failure. It exploded on the pad. It's what they call CATO, catastrophe at takeoff, and a lot of people got killed, and it really wiped out many of their most important technicians and pad leaders. So that was a problem. They also were planning to do a lunar landing test around Earth orbit, the equivalent of Apollo 9. And this was February 26, 1971. Then you have June of 71, the N1 rocket. Again, it launched and failed at 50 seconds into launch. And then the Soyuz here did a lunar landing test in Earth orbit. So they were really trying to make the progress here. And then in November 23rd, 1972, which is literally a month before the last Apollo mission, Apollo 17, the N1 failed at launch at 100 seconds. So they really never got an N1 rocket to launch successfully. As I said in the previous slide, there 4 of these N1 test launches occurred, twice in 1969, once in 1971, and one in 1972. All were failures, even though there was a tremendous amount of hard work to try and improve the rocket with each time. And in each case, it really came down to the engines. This rocket had a cluster, I think, of 36 small engines around the bottom, and they all had to fire with equal thrust in order to develop aerodynamic stability, pressure stability between the stream flows of the thrust from all of those small rockets. And a couple times, a couple of engines would shut down in the middle, and it would cause some turbulence and eddy, and then that would cause a force which would break open a pump or a pipe and a seal. There'd be a fuel leak, and sayonara, nuclear bomb types of excitement would happen. Okay, I believe this is the July 3rd explosion down here in the right corner. You can tell that it was quite the fireball. And here is the satellite picture I was telling you about, that the CIA had reported to NASA that they were getting prepared perhaps to launch a man to the moon. And this is the reason that Frank Borman got his phone call from Deke Slayton: come back here, we've got to talk about maybe changing your mission and sending you out to the moon with Lovell and Anders. Here is the N1 rocket compared to the Saturn V, just to give you that scale. They really were similar beasts in terms of their height, mass. And here's an example of one of the liftoffs of the rocket. Of course, it catastrophically exploded later. Here we are pre-launch. You can get a feeling for how big it is with the people standing down here below it. And then again, I've shown this image of it being transferred horizontally. Now, one of the things you might recognize from the American program is that they had a vehicle assembly building, which I really didn't discuss in this class, but they would use cranes and they would build the rocket vertically upward on the launch pad itself with the launch tower ready to go. And then they would roll it out on the tractor out to the launch pad. So it was built vertically, tested vertically, and integrated vertically, and then it was transported vertically, whereas the Russians did the opposite. They built their rockets on their side, and then they lifted them up slowly on a crane. Okay, so here is the anatomy of the Soviet manned lunar program, if you will. As I said, there were 3 parallel programs. One was run by Chelmy, the other one sort of Korolev, and then inherited by Mission. And that's why I'm showing them parallel to each other here. And then the other one that was run by Barman. So the first program was the Lunar L1 or Lk1 program. Again, design chief was Chelmy. And his goal was to beat the Americans to the circumlunar flight. All right, basically the equivalent of Apollo 8. As you can see, they were making pretty good steps in that program with their Zond spacecraft. Then the Lunar L3 was the central program that was being run by Korolev and then by Mission. And this one was actually the program designed to land the Soviet man on the moon. Now, with the Lunar L1 program, it wasn't required that they had as much heavy lift capability, which is why they were able to use their Zond spacecraft. But with the Lunar L3 program, where they wanted to bring them in, they also had to bring up then their lunar landing module, their equivalent of that. And that required additional lift capability also to get that in and out of orbit. The third lunar program was Zvezda, and this is the permanent lunar base. So the Soviets actually, in addition to thinking about beating the Americans to the moon, were also thinking about a program beyond that with a permanent presence on the moon. And I have to say, that was never in the cards with the Americans and in the United States. And part of that was that we had a switch of president from 1968 to 1972. Johnson had always been a big supporter of the space program. He wanted us to succeed in John F. Kennedy's challenge. He wanted to honor John F. Kennedy in that way. In 1968, Richard Nixon became president, and he really was not interested in the space program. A tremendous number of visions were presented before the Nixon administration of visions of going to Mars by 1985, permanent bases on the moon. In the end, everything got completely chopped except for the space shuttle program. And then the budget on the space shuttle program had been cut back so much that the original abilities of that shuttle were cut back. And one of the reasons that more people died on the shuttle than any other spacecraft is because of those budget cuts and the design direction that it had to be taken, which turned out not to be a safe one in the long run. Okay, so that was a little bit of an aside, but in the end, the Americans really had no permanent lunar base plans whatsoever. It had never been budgeted, or no program had been built. Okay, so what are the key elements for L3 and these projects? So here's the L1 planning. This is the Chelmy's project here. And I just want to go down this series of things as they planned them, all in 1967, which is about the time that we were actually on the ground, because in January of 67, as we know, Grissom, White, and Chaffee had burned up in the Apollo 1 fire. And so the American program was grounded. But they had definitely planned to do all this. And as you saw, they had their Zond spacecraft going up, and they wanted to have their manned lunar flyby as early as, get this, July of 1967. So they would have beat us handily if they had succeeded. More manned lunar flybys. Now, these are flybys. These are not going into orbit. Going into orbit is a whole nother level in which you have to do your lunar orbit insertion burn, and you have to have a lot extra fuel. There's a lot of extra weight, which means you have to use the moon rocket. So by not having the spacecraft go into orbit, they were able to use a much lighter lift vehicle, and that's what they had with their Zond spacecraft. Anyhow, you can see that they had this plan for a lot of manned lunar flybys. They would have learned a great deal about how you get to the moon and navigate to the moon, how you navigate back to the Earth, how you enter that re-entry corridor, that 2-degree width slice of coming into the atmosphere and how to re-enter. They would have really mastered that before putting a man up. As L3 was moving along, as again, this is how they were outlined in 1964, L3, which was Korolev's program, they basically had developed a docking command module called the Lk, and then they had built a docking lunar lander, which they called the Lk. And they were going to send this around unmanned in December of 1967, and then a second one in February 68. And then here we are, April of 1968, they wanted to man the command module, but not necessarily land. This was similar to the Apollo 10 mission. No, actually, sort of only part of the Apollo 10 mission. And then finally, in August of 1968, a piloted lunar lander going down with an unmanned landing, and then the first man on the moon in September of 1968. Now, we didn't fly Apollo 7 until I think it was October of 68, and then it was Apollo 8 in December of 1968 where we orbited the moon. So this was a situation where at least the plans that the Soviets had, they would have beat us to the moon, landing on the moon before we even orbited the moon. By 1965, it was decided that Chelmy would no longer be responsible for any high priority projects. And this is one of the things that would happen in the Soviet Union. You know, one day you're in and you are the teacher's pet. And I mean that quite literally. You know, this is the premier of Russia. And if you're in with him, then you get all the candy, you get all the money. And when you're out, you're out. And so Chelmy was disgraced and he was pushed out. Korolev died suddenly in 66. And this was a crippling blow to the entire program. Eventually, after the dust settled, Mission was named as Korolev's successor. And it turned out that Mission was no Korolev. He just did not have a lot of the capabilities that Korolev had. Okay, so on this slide, we have the lunar landing module compared to the Luni Korabel, I believe is how you pronounce this, which was the name for their lunar lander. And also we have an example of what we called our command module service module, or CSM, command service module. I'm going to call it the LOK. The LOK would carry 2 men, whereas the American command module would carry 3. And then it turned out that if you flew in the Lk, that only 1 man would be going down to the moon. It turned out that this bottom spacecraft was half the mass of the 3-man Apollo spacecraft. So it was a lot lighter. Okay, and then it turns out that the Lk here was about 40% of the mass of the lunar landing module. And here again, we have on the at the Space Museum in Moscow, we have an example of an Lk. Now, the Soviets didn't publicize their program at all. And it wasn't until the fall of the Soviet Union and the thawing of the Cold War, which happened in 1989 through sort of 91, that these records became open to the West, and we actually learned about the Soviet moon program. It's clear that they had continued to push forward this program into the early 1970s while still denying its existence, because we know that we had the last failure of the N1 happening just basically a month before Apollo 17 flew. Okay. I just want to point out these 2 books, particularly this book here on Korolev. If you're interested in this man's life from, you know, it's a biography from his childhood to learning mathematics and understanding, learning about rockets and gliders and airplanes and how he became an aeronautical engineer, and then how he went through learning to get interested in the rocketry program, formed the Rocket Society, GERD, and then, of course, worked for the military, then got purged by Stalin because of Mission, and then came back under arrest, still working for the government, then went to the Soviet with the Soviets to Germany to capture the German scientists and the rocket leftover parts and bring them back, and then building the R7, and then the glorious years for him of Sputnik and Yuri Gagarin, and then how he had to deal with the politics of the Russians, especially Nikita Khrushchev. It's a fantastic book, and I really recommend it if you have some interest in it. Okay, so this is a comparison slide that I want to show that kind of shows you what's going on in the Soviet Union and Russia during the same time as what the United States is doing. And we'll start back here near the beginning of the space race. And you can see there they have the Vostok program, the 6 Vostok missions, and we have the 2 Voskhod missions, the second one being the spacewalk by Alexei Leonov. Here are the Mercury 6 missions. And then here's the Gemini missions. These are 2 test missions. And then these are the Gemini 3 through 12. And we can see that Voskhod basically was on pause for a great deal of time until the late 60s. And meanwhile, they started their Soyuz program, all of this material up here and here and then here. Meanwhile, in the late 60s, you see the Apollo program start to kick in, and it ends here with Apollo 17 in 1972. And then we have the Apollo-Soyuz test mission that happens in 1975. Meanwhile, the Americans had launched their first space station called Skylab, okay? And the Russians had launched their first space station called Salyut 1. Okay. As you can see, as far as American space stations go, that was the end of it for the Americans. The Soviets, on the other hand, had Salyut 3, 5, and 7. And here's 4 that overlaps with 3 and 5, and here's 6. Then somewhere about halfway through Salyut 7, they launched the Mir, and that's been one of the most successful space stations ever. And in fact, a lot of American astronauts spent long duration periods of time as crew on Mir. Relative to these, you can see the Skylab. Now, what's the difference between this and this? Well, these are the manned Skylab missions, but this is how long Skylab actually stayed up in orbit before it deorbited. And so here are some of the Skylab missions that are being discussed here. And we will have a lecture where we talk about the shuttle missions and the Skylab missions. Here are all the shuttles that launched over the years of the program, and that started in 1981 with the Columbia first launch, and then ended here with Atlantis at the very last mission. And we can see here, if we look at Challenger, it basically exploded in 1986, and then Columbia exploded or re-entered and was torn apart on re-entry in 2003. So we'll be talking about these things and this shuttle program. Now, you may have heard of Spaceship One. That is Richard Branson, Sir Richard Branson's Virgin Galactic spaceship, and he's had 2 successful flights with that before 2010. You may have heard that they later had their Spaceship Two, and they had a disaster where one of the astronauts was killed. And we're going to talk about post-2010 in coming future lecture here. And then the other thing here is that the Chinese entered space with their Shenzhou program, and they put their first human in space from their own country with their own technology and launch equipment back in 2003. And by 2010, they had launched 3 of these manned missions. So there's also much more activity that's happened in the last 10 years from 2021 through 2010 in the Chinese program. And we're going to have a fairly extensive lecture on the Chinese program and its development. So talking about the Russian space stations, this is the Salyut 1 through 7 series. I'm only showing pictures of 1 and 7 rather than going through all 7 of them. Here's the first one here. You can see this is the Soyuz spacecraft, and this is the Salyut 1. It's very small. It only was crewed 1 time. Here's the Salyut 7, and it was really the workhorse of the Salyut sequence. went up in May of 82 and lasted until June of 86. So this is during the period of the first 4 years of the shuttle missions as well, which went from 81. And then it was in January of 86 that Challenger exploded. But that was to put it in context to the American shuttle program. It was aloft for 4 years and 2 months, and it was visited by 10 crews. So it was a pretty busy space station. So these were the world's, Salyut 1 was the world's first space station. So that's actually a really cool thing that they had the first, sort of environment for permanent station keeping of humans in orbit. Here is an example of the Salyut 1 and the Soyuz spacecraft that's docked to it, so you can see how big it is inside. And of course, they got much bigger with time, so that by the time we get to Mir, it's got quite a few modules. So here's Mir, launched in 1986 and lasted until 2001. Okay, in Russian, Mir really stands for peace or world. Here's an actual photograph of it. So you can see it in comparison to the size of the globe of the Earth. And then here's the actual space station itself viewed from the Space Shuttle mission number 89. The STS stands for Space Transportation System. That's one of the acronyms for the Space Shuttle. So this is STS 89. And it rendezvoused and docked many times with Mir. Many of the space shuttles did. And so this is during an approach for docking, this is one of the pictures that STS 89 took. It's actually quite beautiful. This is what the complex looks like. You have these multiple modules, number 2, and then the original blue one here, and then the core, Mir core here. And then I don't know how to pronounce these names, but these were all add-on modules. You can see that could actually handle some additional modules or have some docking here. And then here was the docking of the Soyuz spacecraft. Mir flew 15 to 16 orbits a day. It was up for 15 years and 31 days and did 86,331 orbits. It was occupied for 4,592 days out of 5,510. And there were a total of 66 crews and missions that went up. So it was a very, very productive space station. Little known is that there was the Buran snowstorm, as it's called, Soviet space shuttle that was built. And there's no doubt that there was a lot of copying from the American space shuttle. A lot of technology was kind of lifted, stolen, borrowed, however you might think of it, okay? But they did change some design aspects very fundamentally. And you can see here is the American space shuttle, which we will talk about the anatomy of this spacecraft in the future. But in short, it has 2 solid rocket boosters here. And once you light a solid rocket booster, it must burn all of its fuel before it will go out. Once it's lit until it burns out. This is a large fuel tank of hydrogen and oxygen, which feeds the shuttle engines here. And so when it lifts off, it's getting power from the shuttle engines plus the solid rocket booster engines. It eventually drops the boosters as it's going into Earth orbit, and they fall back to the ocean and they're reusable. And then the tank itself will fall and burn up and not be reusable. With the Soviet Union, the shuttle itself has no engines. It has no main engines like the United States shuttle does. It actually is hooked up to something called inertia. And so this inertia is in itself a large tank of liquid fuel like oxygen and hydrogen, and then a series of rockets here that then are used to lift Buran up into orbit. And inertia is actually mostly expendable. Now, Energia was launched twice successfully, once in May of 1987 and once in November of 88. And then it was just retired after that. And mostly that's because what happened was the Soviet Union basically fell. in 1989 through 1991. And so there really wasn't any money to continue the program. And then it turns out that the uses for it that were designed into it had changed because the nature of the political system had changed. I'll talk about that in half a second. Buran could lift 66,000 pounds to low Earth orbit. By comparison, the shuttle could lift 260,000 pounds to low Earth orbit. So it was more powerful, okay? Now, this craft was really designed for military uses. I got the quote here in green. We had no civilian tasks for Buran, and the military ones were no longer needed after the fall of the Soviet Union. It was originally designed as a military system for weapon delivery, maybe even nuclear weapons. Now that's kind of astonishing when you think about it. They were still in the heat of the Cold War in the 1980s. And it turned out that they just let Buran mothball, and they put it in a hangar, and the hangar decayed, and finally the roof of the hangar fell in on it, and that was it. They never refurbished it. It turns out that they did one flight of Buran, so they did test it. That was in November 15th of 1988, and that would be the second successful flight of Energia. It did 2 orbits over 3 hours and a half. And then after that, it was canceled. They never got it off the ground again before the Soviet Union was dissolved. And then, like I said, it was in the hangar, but the hangar collapsed in 2002. And that was the end of the Soviet space shuttle. Now, as I've written here, in 2015, there was a Russian review panel. They reconsidered whether they would rebuild Buran, and that died. Nothing happened. So in 1991, you could say that the Soviet Union is dissolved, and Boris Yeltsin has become the first president of Russia. As we talked about briefly, the Russian space program was broken into competitive design bureaus. And so one of the things that happened under Yeltsin was the formation of the Russian Space Agency itself. And it was formed in February of 1992 under a decree of President Yeltsin, okay? In 2015, the agency was renamed Roscosmos. And so now in the modern world, we speak of Roscosmos in the same way that with the United States, we speak of NASA. This is just some information here that's providing you some information, some quotes from various white papers and projects that were being planned for the future through Roscosmos. Of course, none of these have really been funded. It's not clear what kind of moon program that the Soviets have. These are programs which are supposed to have, that provide some presence on the moon by 2030. You can see here that they want to have some crude launches around 2025. And there's no signs that any of this is really transpiring. So in the end, this is my last slide for this lecture. I would like to say that the space capsule payload contains Roscosmos. How's that? So then I just want to show this as a sort of a fun ending before we move on to the Chinese space program and the space shuttle and Skylab. Here we have the emblem for NASA. Here we have the emblem for Roscosmos. And this is the emblem for the Chinese National Space Administration. The Chinese, every part of their symbol has meaning. And in fact, that symbol evolves as they further and further have success with their program. Of course, to the right, we have the well-known Starfleet Command, United Federation of Planets symbol. And I think it's one of those situations where sometimes you wonder if Star Trek is really going to happen in the future, because our symbols seem to be evolving into the Starfleet Command symbol. So that's what I wanted to end with as kind of a fun ending to it. So again, when we come back, we're going to go back to the American program. We're going to talk about the space shuttle, and we're going to talk about the Skylab program. And then after that, we're going to talk about the Chinese. And then after that, more of the Asian space programs. So I hope you enjoyed today, and we will see you next time. Take care.